So two things we're going to look at next in regards to confidence intervals has to do with how to interpret both a confidence level and a confidence interval, as well as how to take a look at some of the different components that are involved with constructing a confidence interval. So as we kind of look at some different things first with interpreting. So whenever we're interpreting a confidence level or a confidence interval, this is sort of the structure that we want to use, or the sentence structure that we want to use in order to do each one of these. So if we're looking to interpret a confidence level, what we would want to do to say that is we would basically say this: to say that we are, and I'm using 95% as sort of our basis for the example here. To say that we are 95% confident is shorthand for 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. So in terms of the structure there, what you're going to notice with this is that there's going to be two different items or two different parts of this structure that will change based on the problem that you have. So what obviously first will change is the confidence level that you have. So keep in mind that most confidence intervals are of the 95% variety there, but if the confidence level is different, then you would want to put in the beginning here what that confidence level is. And then what's also going to change from this is the sample size that's chosen from the population, and then finally what the parameter of interest that we're measuring, that will also change based on the information that's given in the problem. So in terms of the other parts of this, the structure of this will stay the same, and that's what I'm sort of underlining here. That will stay the same regardless of the information that's given in the problem. So that's basically some different things with interpreting a confidence level. If we're talking about interpreting a confidence interval, to interpret and I'm using sort of C% here, so that would be 95% or 90% or whatever your confidence level would be. To interpret a C% confidence interval for an unknown parameter, what we would say here is that we would say we are C% confident that the interval from, and then you would put what the confidence interval is right here, captures the actual value of the population parameter in context. So that's what it is that we're measuring, or what it is that we're looking to estimate about the population. So that's just some different things in terms of the sentence structure that you want to use to interpret both a confidence level and a confidence interval. So some different things, okay, about confidence levels and confidence intervals, one of which is this right here. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. So keep in mind, and this is a very common mistake when you look at some different things with confidence intervals, is that sometimes people mistakenly associate the confidence level for some type of probability that something that would occur. That is not true. The confidence level is what we use to determine how many standard deviations away from the estimate that we're going to carry our interval both above and below what the value of that estimate is. So some different things here in terms of confidence levels and confidence intervals. And the question here says, how much does the fat content of Brand X hot dogs vary? To find out, researchers measured fat content of a random sample of 10 Brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. And the first question here says to interpret the confidence interval. So if I'm interpreting the interval, what we would say here is that we are 95% confident that the interval from 2.84 to 7.55 captures the true standard deviation of the fat content of Brand X hot dogs. And just notice what I'm underlining here is the parts of this that would change based on the information that's given in the question that's up here. Okay, so that's number one. For number two, interpret the confidence level. What we would say there is, in 95% of all possible samples of 10 Brand X hot dogs, the resulting confidence interval would capture the true standard deviation. So once again, just notice there, I'm just simply underlining the parts of the interpretation that would come from the information that's given in this example right here. So for question 3, it says true or false, the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. So remember that confidence intervals do not measure the probability that something occurs. Okay, the confidence level that we use, okay, is going to determine how many standard deviations above and below the estimate that we get from our sample, how many standard deviations above and below the mean that interval is going to be. So remember that the confidence level has nothing to do with the probability that something would occur. So the answer to this would be false. So in terms of constructing a confidence interval, there's a couple different things that we're going to look at here. One is the estimate that we get from the sample that we take from the population, and then we have the margin of error, and that's how far above and below this estimate right here our interval is going to be. So the estimate basically is the value that you get from your sample. The margin of error comes from essentially two things. One is it's going to come from the type of confidence interval we're going to compute. In other words, what the confidence level is, and then also what the standard deviation would be for the sampling distribution. So those are the two things that sort of get factored into what how the confidence interval is constructed. It's the estimate from the sample and then the margin of error. And the margin of error is essentially a function of the confidence level and what the standard deviation from the sampling distribution would be. So just as a sort of more general sort of formula here, the statistic, okay, is the value from the sample. The critical value is essentially the the z-score that's associated with the confidence level, and then the standard deviation of the statistic is the value that we get from the sample. So as far as some different things that are involved with the properties of a confidence interval, so just keep in mind that the critical value, and that's based on the value of the confidence level, that depends on the confidence level and the sampling distribution of the statistic. And we're going to get into looking at some different things with conditions in a moment. But the greater the confidence requires a larger critical value. The standard deviation of the statistic depends on the sample size. So just remember, bigger sample sizes results in a lower value for the standard deviation. So the margin of error gets smaller, this value here, when I multiply these two, this value gets smaller when the confidence level decreases and the sample size increases. And we'll get into looking at some different things about how your confidence interval changes as a function of both the confidence level and the sample size as we get into some more examples. So before you calculate a confidence interval, there's conditions involved. Just like there were conditions when we were talking about sample means and sample proportions, there's conditions involved with confidence intervals. So there's three conditions. There's the random condition, meaning that your data should come from a well-designed random sample or a randomized experiment. There's the normal condition. If we're talking about quantitative data, remember that is, we know that the sampling distribution is normal if the population distribution is normal, or if the sample size from that population is 30 or more. If we're talking about categorical data, then we have to use these two here to determine if the sampling distribution is normal, and that's n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10. And then the last condition is independence. And independence basically is if we're sampling without replacement, and that's the only time this would apply. If we're sampling without replacement, then the 10% condition needs to be true, meaning that your sample size cannot be more than 10% of your population size. So, question here, it says, suppose that you know that the distribution of finishing times for a certain crossword puzzle has a mean of 25 minutes and a standard deviation of 8 minutes, and is moderately skewed left. You take a simple random sample of 45 finish times from the distribution and calculate the mean finish time. So part A says to describe the shape, center, and spread of the sampling distribution of X bar. So if we're talking about the shape, center, and spread here, the shape for this, because the sample size is more than 30, we would say that the shape for this would be normal. The center for this would be the same as the center of the population, which in this case would be 25 minutes. And then to find what the spread would be, we would do the population standard deviation divided by the square root of the sample size, which when I go to work that out, comes out to be roughly we'll call this 1.19. And then part B says, find a number k such that 95% of the values in the sampling distribution will lie within k minutes of the mean of the distribution. So in other words, how many standard deviations from the mean would 95% of the data values be? So from the empirical rule, we know that if we have a normal curve, which we know just from up here that the shape of this is normal, we know that k would have to equal 2 because approximately 95% of all data values fall within 2 standard deviations of the mean under the normal curve there. And then for number 3, if we take repeated samples of size 45 from this population, what proportion of the time will the interval x bar plus or minus k contain the number 25? So to find that, I'm going to take the estimate that we came up with, which in this case was 25 minutes, plus or minus the margin of error. And the margin of error I'm going to find by multiplying the critical value, which in this case is 2 because 95% of the data values fall within 2 standard deviations of the mean. I'm going to multiply that by the standard deviation of the sampling distribution, which when I multiply that out, this comes out to be 25 plus or minus, we'll call this 2.38. So when I go to work that out, I get a value of, or a confidence interval of, this is going to go from 22.62 through 27.38. So I get something like that there for the confidence interval based on the given mean and standard deviation. So for question 2, it says an insect ecologist reports a 95% confidence interval for the mean length of a full-grown aquatic larvae of the phantom midge Corybus albatus to be 6.9 to 8.5 millimeters based on a sample of 9 individual larvae. And question A says, what are the point estimate and margin of error associated with this confidence interval? So the point estimate for this is going to be essentially the middle value of 6.9 and 8.5. So if I did here 6.9 plus 8.5 divided by 2, if I found what the midpoint for that was, that would tell me what the point estimate for this would be. So if I did that, this comes out to be roughly about 7.7. And then as far as the margin of error goes, the margin of error is how far is each of these values from that point estimate. So you can see here that the margin of error, I'll just put this over here, margin of error, if the distance from 8.5 to 7.7 and from 6.9 to 7.7 would be 0.8. And that's the margin of error that's involved there. That's what I added to 7.7 and subtracted from 7.7 that got this confidence interval here. And part B says the ecologist stated that all necessary conditions for constructing this interval were met. What does this tell you about his methods and the population of insect larvae? So remember, if all necessary conditions are met, then that is the samples were chosen randomly, so that random conditions met. We know that the population must be normal, or the sampling distribution must be normal, based on either the population distribution being normal or the sample size that they took being 30 or more. And we know that the independence condition must have been met because if they're sampling without replacement, then that 10% condition must have been met in order for all necessary conditions to have been satisfied there. Part C says, if the ecologist had reported a 99% confidence interval instead of 95%, how would it have been different? So just remember that whenever you increase your confidence level, That's going to make you more confident. And what that will do to the interval is that makes the interval wider. So if you want to increase your confidence level, you want to include more numbers in that interval. And that is essentially a function of how the confidence level affects the values that are in the interval. And then for part T, the ecologist was unhappy with how wide this interval was. What should he do to produce a narrower interval with the same level of confidence? So if you want to keep your confidence level the same, but you want to take your interval and make it not as wide, what you would want to do is to increase the sample size. And by increasing the sample size, what you will do is you will decrease the standard deviation, and decreasing the standard deviation will essentially decrease the margin of error. And if you decrease your margin of error, then you will take your interval and you'll make it so it's not as wide. So those are some of the different things that are involved with the basics of confidence intervals. Two things that I would point out to you are very important to make sure that you understand here. One of which is how a confidence interval is constructed. Very important that you understand the basics behind that right there. And the other thing that's very important of some of the things that we talked about, and that is how you interpret a confidence interval. So just make sure that that's something, the sentence structure that we use for something like that, just make sure you're familiar with how to do that for a confidence interval.